In this problem, we want to find the sine of pi over 12 without using a calculator. So what we're going to do is we're going to use these new identities that we are working with, the sum and difference identities, to help us figure this out. So I'm going to change the radians to degrees. So pi is 180. 180 divided by 12 is 15. So I'm really wanting to find the sine of 15 degrees. So what I want to do, since I'm using the sum or difference identities, I want to find two angles that I know the sine of and add or subtract them to get 15 degrees. So it looks like we have two choices here. We could use 30 minus 45 or 60 minus 45. So I'm going to use 30 minus 45. So this is going to be sine, so this is equal to the sine of 45 degrees minus 30 degrees. And now we're going to use the sine of a difference to help us solve this. The sine of a difference is the sine of the first angle, which is 45, times the cosine of the second angle, which is 30, minus the cosine of the first angle times the sine of the second angle. So we need to figure out the sine and cosine of 45 and the sine and cosine of 30. So if we use our special right triangles to help us here, the 45, 45, 90, sine is opposite over hypotenuse, so that's going to be 1 over root 2. And the cosine is adjacent over hypotenuse, so that's going to be 1 over root 2. And then if we draw our 30, 60, 90, the sine of 30 is opposite over hypotenuse, so it's a half. And the cosine of 30 is adjacent over hypotenuse, so it's square root 3 over 2. And now if we rewrite the 1 over root 2's, let's get rid of the square root in the denominator. It's going to be square root of 2 over 2 times square root 3 over 2 minus square root of 2 over 2 times a half. And we're going to multiply fractions. So square root of 2 times square root of 3 is square root of 6 over 4 minus square root of 2 over 4. And so that is our final answer. So the sine of 15 degrees is equal to the square root of 6 minus the square root of 2 over 4.